Do you know what is the most frequent cause for combined cycle power plant unavailability and forced outages? It's the failure of the combustion turbine and Hertzog control systems and associated field instrumentation. My name is Craig Nicholson and I'm going to talk through industrial control system upgrades. So, power plant control systems in the traditional sense really serve two primary purposes. One was automated control and two was protection of the equipment against any inadmissible operating condition. Typically, the trigger for an upgrade would lie in the spectrum between decreasing system reliability and the challenges associated with upgrading. Essentially, upgrades may be perceived as a zero-sum game, with little upside, creating a tendency to defer upgrades and plant maintenance budgets. Well, a lot has changed in a decade. Technology advancements in the field of machine learning, advanced analytics, and artificial intelligence are opening up opportunities to improve productivity and performance of power plants, thus increasing competitiveness and economic life. But the reality is the foundation of a power plant's digital strategy starts at the process data level, the plant's control system. Now, in addition to control and protection, a modern control system can vastly improve access to process data in a secure manner, avoiding legacy system bandwidth limitations and cybersecurity risks associated with the vulnerabilities of aging communication protocols. So, to position a plant for future success, how do you best manage control system maintenance? How do you mitigate known upgrade challenges such as operations and maintenance change management, plant personnel training, and short-term system reliability risks during and after the upgrade? Well, it starts with a structured approach. It's possible to develop a holistic controls maintenance plan that can avoid many of the costly pitfalls that keep plant managers awake at night. Here's some of the key areas that should be addressed. Start with your business needs. A controls maintenance plan should dovetail in with the business strategy in terms of current and anticipated performance capability and life cycle of the plant, as well as profit-sustaining OPEX and CAPEX requirements. This will serve as a basis to frame what success really looks like in terms of long-term controls maintenance and how this fits into the overall maintenance strategy for the power plant. Too often, when upgrades are required, attention is drawn to a vendor's system's features or marketing jargon, which can result in selection of a poor fit for the power plant. Look at assessing your power plant. A system evaluation will identify current infrastructure as well as existing pinch points and anticipated future issues. Typically, a plant has multiple systems that all should be part of the evaluation, really with the goal of trying to consolidate wherever possible at the plant level. Such an assessment helps prioritize upgrade needs, strategic spares for legacy systems, and critical system maintenance activities as vulnerabilities are mapped out and addressed, such as an obsolete human-machine interface, or HMI, or aging Windows systems, which have expired service support that typically lasts about 10 years, all of which exacerbates cyber intrusion risks. The next step is to put together a migration plan. Once a plant has been assessed, coupled with knowing future requirements and business needs, you will be well positioned to further develop a maintenance plan and upgrade strategy. This will form the basis for development of a request for proposal or an RFP, which may be tied into a service agreement or a standalone transaction. The RFP will serve to clearly articulate the plant's wants and needs, thus providing clarity to bidders, allowing for comparison of proposals. This is important as not all upgrades are the same. For example, without clarity on the ask, one vendor may offer a partial upgrade utilizing existing infrastructure, while others offer a full system replacement. Knowing which path is optimal for the plant will be evident from the prior assessment and the goal setting phase. It's common to stage upgrades such that one unit is upgraded before the other, and in such cases additional interim steps and interface considerations to legacy systems may be required, all while ensuring safe and reliable plant operations. How bidders respond to such plant-specific requests will serve as a key part of the bidder evaluation. Now let's move to development and implementation. So upgrades are an engineering-intensive project. In fact, the split in cost between engineering and hardware is typically around 70% to 30%. 70% engineering, 30% and hardware. Such, it's key to get value for your dollar on the engineering scope. Generally, controls projects can be broken into distinct phases, such as the hardware design, procurement phase, software design, and testing. In order to ensure a quality outcome, the prudent approach with a vendor is to trust but verify at each phase of the project. Once a vendor has frozen design and started purchasing hardware, his system is locked in. Prior to this, a technical assessment of the system's architecture is critical to ensure consistency with prudent industry practices, as well as conforming to contractual requirements and plant requirements. Just as important is assessment of the software design and methodologies employed, checking for conformity in HMI and control philosophy that's congruent with current plant operations. Typically, poorly engineered systems are a result of poor communication either during handover from the commercial team to the execution team or within the execution team of the vendor, followed by a lack of process experience and rigor. A seasoned controls engineer with good process knowledge will have the ability to understand the potential failure modes that the system may be subject to and test the robustness of design to such failures. And here's the key: don't just test for working features, test for failures. With the right expertise and due diligence, a poorly designed and tested system can easily be avoided, sparing control room operators from spurious alarms and system reliability issues for years to come. So you're on a path to an upgrade. What about training or operational maintenance staff? Once an upgrade is deployed, it can feel shocking for the plant personnel. A well-designed system will mimic the desired functionality of the existing systems to try and minimize disruptions to operations. However, inevitably there will be a learning curve. Training programs from vendors are typically an afterthought. For example, a few days training at the end of the commissioning. Personnel training should be really a key part of the controls maintenance strategy and not left until post-upgrade, with emphasis on plant operations and cybersecurity. A training plan may include purchase of a plant simulator, classroom, and/or on-site training, or a combination thereof. So, digital technologies are in a nascent phase, and the potential gains for power plant owners will continue to rapidly evolve. With a structured approach to controls maintenance, you can have confidence in realizing gains in these rapidly evolving technologies, while maintaining and upgrading your plant control systems with minimal disruptions to your plant operations. That's it for this video blog. Please post comments below and we'll speak to you soon. Thanks.